Mr. Palmer here with another quick video on computer science concepts here for A-level computing. Before you watch this video, make sure you go over your notes on serial files, remind yourself what a sequential file is. I'm waiting here for you to go over your notes. So this one's about basic searches, okay? It's a prelude to looking at merging files, insertion sorts, and quick sorts, all right? Recap over what is a serial file, serial searches, and the concept of a binary search, all right? So you should know by the end of this video what is the difference between a binary and a serial search, and when you cannot use a binary search. Simple thing there, which people seem to confuse. All right. So remember, serial file. We've got data being appended in order of arrival. So there's my serial file, and hey presto, as my data arrives, it gets written to the file. There's no specific order. All right. Serial search, it then implies that in order for me to find something in that file, I will need to search through every single item. So if I'm looking for the name Leah in my file, I need to search through every single node. If the node matches my search criteria, then I can return found, else go to the next node until end of file. So you can see in order to retrieve the name Leah, I've had to do 1, 2, 3, 4, 5, 6, 7, 8 searches. Okay, you can imagine if I have a very large file, then it's going to take me quite a long time to search through that data. If I have if I'm going to do the algorithm for a serial search, it looks something like this. I'm going to make my current node 0 and my boolean found false. Okay, this is my flag. So while I'm not at the end of file and not found, I'm going to check if my node 0 at the moment in file is equal to my criteria, then found equals to true, else I'm going to do node plus plus, and then that's the end of my while loop. And so I basically search through my file and it will trigger and exit the loop if I either reach end of file or the boolean found is now set to true. Then obviously if I found it, I can print my result out, else I'll print item not found. A sequential file, remember that the data here is appended in order of the key field. Alright, so here I've got a sequential file, same data as in the previous file, but now it's in order. Here I'm assuming the key field is a name. Alright, same thing, I want to search for Leah. So in my binary search, basically what I'm going to do is I'm going to cut the data in half. Alright, Joe's the middle one. Does Joe match my criteria? No, it doesn't. So I split it in half. Right? In this case, Leah is greater than Joe. So I'm going to basically, I'm going to rewind my animation. Right, let's go over here. Right, so Leah is greater than Joe. So I'm now going to move to the top half of my list, and I'm going to search that middle criteria again. So Taj is the middle one there. Taj is greater than Leah. So now I'm going to go into the lower half of my new list. Okay, and then basically when I compare the return criteria over there, I can see that I've now found a match for Leah. So the same list, 11 items, all right, but I was able to locate the data within 3 iterations of my search algorithm. Right, so the general process here that you can see taking place is I'm going to the middle item. I compare that middle item to my criteria. If there's a match, then hey, I found it. Else, I'm going to determine whether it's higher or lower. My criteria is higher or lower, and then I go move and I split that new half of the list in half again, and I compare it, and I do that same comparison routine against that middle item that I've just returned. Okay, so divide sequence into upper and lower, go match that middle item. If it's a match, I return it. Otherwise, I determine if the criteria is higher or lower, and then go off and do that search again. Okay, and I repeat the process until the process is found, or until there's only one element left. Because obviously, if there's only one element left and it's not a match, then my item does not exist in the list. Alright, if you compare these two search methods, you can basically see a serial file. You've got unordered data. Alright, the maximum possible time it might take to search it would be the time taken to search for one item. Because if you've got 1,000,000 items in the list, it's going to take you, and you're looking for the 1,000,000th item, it's going to go through all 1,000,000 of them. Alright, so the time it takes you to find one item, multiply that by 1,000,000 times for that maximum possible search time. In a binary search, okay, your data is ordered in order of the key field. So as you're splitting in half each time, right? So your first search is gonna, is gonna be your number of items is gonna be divided by 2. So it's n divided by 2. Then it's gonna be n divided by 4. Then divided by 8. Then divided by 16. So each iteration is halving the possible search list. That means that same item of a million list of a million items, you could actually search the entire list within 20 possible iterations of your so maximum of 20 possible iterations of your search algorithm. So you can see that a binary search basically speeds up the process significantly. Right, that's the end of this little video, and I will catch you again with another video continuing on merging and sorting algorithms.